Alright guys, welcome back. We're going to be solving another question from the first chapter of Meriam textbook, Dynamics. And in this question we have 200 millimeter diameter spheres constructed of different metals that are located in deep space, and we need to determine the gravitational force F which the copper sphere exerts on the titanium spheres in two different conditions. The first condition we have D, or the distance between the center of these two, 2 meter, and in the B part of the question we have 4 meter instead of 2. So first of all, let's see how we can find the gravitational force. So our F, or the gravitational force, is equal to G times G is the universal gravitational constant, and actually G will be equal to 6.673 times 10 to the minus 11 meter cube over kilogram square second. And we have the mass of the copper, which we can show it with MC, times the mass of titanium, which we're going to show it with MT, divided by the distance squared. And from this formula we can find the gravitational force between these two spheres. And if we look at this, all we need in here, so basically we have G, our D is a given in the question, we have two different conditions for D, and as long as we can figure out the mass of each of these, we are good to go to find the force. But the question is, how are we going to find the mass? And we know mass is equal to density times the volume of the object that we have. Here we have sphere, and we know the volume of this sphere is 4/3 of pi times the radius cube. And from the question, if we want to find the radius, first of all, we know that each of these spheres, they have the same diameter, which is 100 millimeters. So the diameter is 100 millimeter, and we know this is equal to 2 times r. And here we can find the radius, which is 100 divided by 2, or 50 millimeter, or if we want to write it down based on meter, we just have to divide that by 1000, 0.05 meter. That's our radius. So it seems that we can find the volume of each of these spheres easy. So as I mentioned, the volume of the copper is equal to volume of titanium, since we have the same radius, and that would be 4/3 of pi times r, which is 0.05 cube. And if we calculate this, we get our volume 5.234 times 10 to the minus 4 meter cube. So now that we have the volume in here, we just have to find the mass of each. Let's go with the mass of copper first, which will be the density of copper times the volume. We're just going to show it with V from now on, because the volume, as I said, since the radius is the same, the volume would be the same too. And if we want to go with the copper first, we know the density of copper. So the density of copper is equal to 8910 kilogram per meter cube. You guys don't need to memorize these densities. It will be given in the exam. So usually you'll be provided with a table that you have these densities. So basically we have 8910 times the volume, which was 5.234 times 10 to the minus 4. So if we calculate this, we're going to get the mass, which will be 4.665 kilogram, which will be the mass of copper. And if we want to find the mass of titanium, we have the density of titanium times the volume, and the density of titanium is 3080 kilogram per meter cube. And here we have 380 times the same volume, 5.234 times 10 to the minus 4, and this is going to give us 1.612 kilogram, which would be our mass. So the gravitational force that copper is applying on titanium will be in this direction. So copper is trying to pull the titanium toward itself. So this would be the direction of the force. And if we want to show the force in a vector form, since we are in the opposite direction of x-axis, we have a negative sign, and we only have I component since we are in x direction. So if we want to show the force in here, we can express it as a vector, which will be the formula that we have. I'm just going to write it down again. Our F will be minus G times MC times mt over d squared. So we just need to plug in our values for m, g, and d in here, and we're good to go to find the answer. So in the a part, our d is 2 meter, so our f basically in here will be minus g, which as we talked about at the beginning of the question, this is the value for g. So 6.673 times 10 to the minus 11 times the mass of each. So we found 4.665 mass of copper, and the mass of titanium was 1.612, and in the denominator we only have d squared, which is 2 to the power of 2, and we have our I in here, and if we calculate this, our F will be minus 1.255 times 10 to the minus 10 I, and that would be the answer for the first part of the question. And when we have our B is equal to 4 meter, we'll have the same thing, but we can see that, so our denominator here is 4, and we just have a denominator of, if we would port, our denominator will be 16. So we can simply just divide the F that found here by 4. So basically we can multiply this by 1 over 4, or 1.255 times 10 to the minus 10 divided by 4. And if we calculate this, we'll get our F minus 3.14 times 10 to the minus 11 I, and that would be the answer for the B part of the question. Or we can just simply get back to our formula in here and plug in our D4 instead of 2 to find the answer, just since we already found the F based on D is equal to 2 meter, we just have to divide by 4 to get the final answer. All the units are in here, newtons, and yeah, that's pretty much everything for this question. Hope you guys find it helpful. Let me know if you have any question regarding textbooks that we are covering in this channel, and you guys take care. I'll see you in the next video. Have a good one.